All right, so we're back and we want to do difference quotients with not a linear function but a quadratic function. So it's a little bit cumbersome with the algebra, but we'll do two examples. We'll do this one and one more. All right, the directions are find the difference quotient. You'll be given the function and you'll be given the formula. All right, so notice that we have f of x's value right here. We know it's equal to this this quadratic equation. What we don't have is something, an expression that represents that quantity. So that's what we have to build. So you're given the equation, the formula, but we have a little more work to do. So over here, I'm going to rewrite the problem. So I need to generate f evaluated at x plus h, which means in this x and this x, I'm going to insert x plus h, keeping everything else the same. All right, so now I'm going to come over here and I'm going to build this long, ugly fraction bar. H is still in the denominator. I need what the expression for x of x plus h is, which is right here. So I'm actually going to start the numerator with this expression. Now I'm at the minus sign. And don't forget, you want to put in parentheses all of f of x. Well, what's f of x? It's color-coded up here. It's 2x squared plus 3x plus 1. Okay, and I've got all this space because it's probably going to take it for all this algebra. All right, let me handle what I can. Let me put the h in the denominator. All right, reading from left to right, let's just kind of focus on what needs our attention. Okay, I need to FOIL quantity x plus h, keep the 2 out front until that's been completed. So remember to expand that, that's x plus h times x plus h. And then you're going to FOIL. And since we've done that, it's x squared plus 2xh plus h squared. I'll distribute the 2 in the next step. Let's move on now to the next term, which implies that we want to distribute the 3 inside. So plus 3x plus 3h. Again, I recommend those arrows to make sure we don't forget to multiply, because that's a common mistake, that we forget to multiply by that last term there. And then I'm at the plus 1. Now this is minus 1 to be distributed inside with all these terms. So all those terms will change to minus. Okay, I'm not done yet. Kind of take another look at this. Have I done everything I can to kind of expand? No. So I'm going to have to rewrite it. H. Let's distribute that 2 inside. So that's 2 times 2, or 4xh, plus 2h squared. And then I'll just bring down everything else, because I don't need to perform any kind of other distribution or anything. Okay, hopefully you found it helpful to do that previous work, to tackle what's going on here, in this expression, all that algebra. Okay, what do we do? Because it's awful ugly. Well, we look for things that will cancel. So 2x squared minus 2x squared, 3x minus 3x, and then minus 1 and 1. As a matter of fact, rule of thumb is the whole function that you have that follows the subtraction sign, that should be able to cancel with something that's up front. Okay, notice what's left. We've got, let me build that fraction, h. I've got 4xh plus 2h squared, and then I also have 3h. I'm almost done, but I noticed that in the numerator, every term has an h. This is going to happen for all these quadratic equations. I notice every term has an h. So what I can do is I can pull that GCF out, that h up front, and that will leave me with 4x plus, when I divide out an h here, I'm left with just 2h. When I divide out an h here to pull up front, I've just got the 3. Again, I always encourage you to check by multiplying back in to see if you get back to what you had here. Now notice that we have factors that can divide out. Once you pull that h out front, now this becomes a multiplication problem, and I can divide out these common factors of h. So actually my answer is 4x plus 2h plus 3. And that's it. A lot more complicated than the one we did in the last video where our answer was just a number. But that reason for that was that we were dealing with linear functions and we were finding a slope because that's what difference quotient was. So when you deal with a linear function, you should get a numerical value. When we deal with a quadratic, we don't end up with a one numerical value because the slope of this graph is always changing. It's not the same as the slope through a linear function. So what good are difference quotients? You may be going, oh my gosh, besides creating a lot of pain. Difference quotients are important to calculus because we take limits of difference quotients and that allows us to find the slope at, say, just one point on a graph. Okay, so that's the whole idea. We're making connections up to calculus. I know that's kind of hard to see because we're just doing algebra, but we're just building up until that point. It will help students find the instantaneous rate of change of a graph, which just means find the slope through one point on a graph. Okay, let's do one more problem with a quadratic function. And I'm going to return to the back for my other extra example. This would be the given information and the instructions would be find the difference quotient. Difference, and then we have a quotient. Okay, well, again, we've got f of x. It's equal to this expression. We just have to find something to put in for f evaluated at x plus h. So given this, find the difference quotient. We have a little bit of work to do. Let's generate this, an expression for f of x plus h. So I saved myself some room here so I could put it right underneath. I need to create this, so everywhere I see an x, replace it with x plus h. This is a formula. I'm going to work to the side. Big fraction. F of x plus h is here, but it's also equal to this expression. So we need orange minus yellow. So we'll put orange up front. This is y subscript 2, if you will, minus, that's where I'm at. And then don't forget you need parentheses. Not so important if this is a plus because you're just distributing in a positive 1, which doesn't change anything. Boy, do we have a lot of algebraic work. I'm going to target what's going on here. So keep the negative 2 out front. We've done this a couple times now. I'm going to go ahead and maybe distribute this negative 1. So that'd be minus x minus h. Don't forget the plus 3. We're at this minus sign, so now we're going to distribute in this negative, changing all the signs in f of x, that y value. So plus 2x squared plus x and then minus 3. So in the numerator, we still have a little bit of algebra to do. We've got to distribute this negative 2 inside this quantity. So negative 2x squared minus 4xh minus 2h squared. And then I've finished distributing, so I'm just going to bring all this down. Again, a reminder, the whole function, what falls here behind the subtraction sign, which is now made into an addition sign, all of the function should cancel out with another term. And if it doesn't, we probably made a sign mistake. All right, I see negative 2x squared and positive 2x squared. I see negative x and positive x, and I see a positive 3 and a negative 3. so that these are all contrived problems. I should just end up with terms that have an h in it. So let's see as we transpose that. So I've got negative 4xh, negative 2h squared, and a minus h left. Yes, all three of these terms have a common factor of h. So let's pull that GCF h up front. So I divide out an h here, I'm left with negative 4x. Divide an h out here, I'm left with minus 2h. Divide out an h here, and I'm left with minus 1. That's always kind of a weird factor, but again, like I say, I encourage you to kind of distribute it back in to see if you end up with the same results that you had here, this numerator. Now that we have a factor problem, we can divide out the h's, divide out the h's. So my final answer is what I have left here. Should our answer be ugly? Yes, it should. This represents the slope between 2 points on this quadratic function. It should be ugly because the problem we started with was quadratic. Had it been linear like the first two examples, then we would have ended up with a numerical value. So these are ugly answers. Now, we're going to go only as high as a square, because can you imagine if that was a cube? That would just be over the top with too much algebra. So hopefully that helped a little bit to understand difference quotients.